continue our discussion on this cloud computing. More specifically, we are last class we are discussing about sustainable cloud computing. So, we will continue our discussion on sustainable cloud computing, right. So, what we see the concept primarily the sustainable cloud computing thing, and along with that we will look at that what are the different components, taxonomy for needed for this sustainable cloud computing paradigm or sustainable cloud computing aspect means model of the this cloud computing. So, this is we are continuing from the last class. Just to start with a quick recap what we have seen in the last class. This CSP is what we see that heavily rely on these CDCs or the data centers which are there to cater this ever increasing need of the user, especially in today's world with so many or millions and billions of IoT devices are in place, and so this overall computing requirement is increasing exponentially, we may say, right. So, to cater to this, these cloud service providers are increasing their capacity, like in terms of increasing number of their distributed data centers, packing more servers into the data centers and which in turn lead to more heat generation, more power requirement, which in turn have more cooling mechanisms into the place, right. So, all those things brings about a problem or a challenge for the sustainability of the computing system, in our case cloud computing system, right. If you see in a more holistic manner, so if you see that over years or over decades, this the overall size of this our chips and semiconductor devices has reduced to a great extent, whereas the computational power has increased, right. In other terms, if we see that other than there is a limit for the particular say technology like VLSI technology or whatever you look at it, that how much compactness or how much packing you can done. On the other hand, once you make this type of very compact circuits, is generated tremendous amount of heat, right, which need to be dissipated, right. So, that also in if we see in the thermodynamics term, I am not a nowhere a expert in that area, but intuitively we see that is also a limiting factor, that how much heat you can tolerate, right. So, if you see that say GPUs or HPC type of architecture, so there is a enormous amount of this so called cooling mechanism, heat sinks, which is required to cool the systems, so that it can perform at its optimal level, right. So, rather in modern day data centers, especially housing large servers or HPC type of servers, what we see that the somewhere the cost of the this IT infrastructure and cost of this environment like heating mechanism, power, cooling mechanism, power and say environmental other control things is basically leading to the same cost. Like if it is cost x, this IP infrastructure, this is somewhere it is, if you look at it, it is another x type of things, right. So, that means in order to make this sustainable, or in order to this cloud computing sustainable, what we want to look at, we need to look at all the factors, like starting from this computing wise, how much how much we can go on increasing, along with that how to handle this say cooling mechanism, what to do with this what we say this excess heat, or sometimes what is referred to as waste heat, right, what to do with this waste heat thing. And there are definitely things like power and types like that, right. Unless we take whole mechanisms like computing, plus if we say this per se this overall environment to handle the whole system into together, the making it sustainable is always a challenging job. So, what we see that financial and carbon footprint related to the cost of running of such infrastructure negatively impacts the sustainability, right. So, at some point it will basically say that this is the you cannot cross these things, right. Like if I have a say 10 feet cross 10 feet a room, or maybe a particular size x cross y, a room with AC of so much AC and things like that. So, the number of server, even the space allowed, is something related with the how much heat generated and cooling is there. It is not only that how much your space or power allows, also the how much heat it is generating and how whether there is a way to cool it down and type of things. That is one aspect. If I say that the cooling mechanism things are there, then means actually all these factors, these cooling mechanisms, heat generations, power, computing, they need to be looked into a more integrated fashion, right. What this sustainable cloud computing or sustainable computing in general tries to address is. So, the focus is on minimizing the energy consumption and carbon footprint and ensuring reliability of the these cloud data centers. So, this is the goal or one of the major objectives of this sustainable cloud computing. Now, if we look at this picture also last class we have seen. So, this is a typical model, the conceptual model proposed by this in this particular reference in this particular journal or paper. So, what we see one side this cloud architecture is there, where we have IaaS, PaaS and SaaS, right. On other things what we have other models, other modules, right. One is that this power manager, which takes care of this power, and once we talk about the power, it can be from our conventional sources, right, which basically based on this fossil fuel etc., or we can have renewable sources, right, like it may be solar, it can be wind, things like that, right. So, that is the things, and once we have this type of stuff, then there are a lot of things that when to switch to conventional to renewable and things like that, and there are pros con in running the IP infrastructure at the in the whole stuff. Like initially we may start with the conventional sources, then switch it to that renewable sources, and if required come back based on the load and type of things, right. So, that is another thing is a cooling manager, like temperature control, heat exchanger and type of things, which takes care of that so called air conditioning infrastructure. And there are remote CDCs, right, where that data centers, there are remote data centers where we may require to given all those things constant, power and cooling mechanisms, other things constant. So, I can have with the load increasing or the user load increasing, I can basically migrate the VM from one to another, and overall say power requirement or heat dissipation I can we can manage, right, whether that is possible, right, that type of thing. So, if there are remote CDCs which to migrate and migrate, what should be my migration plan and things like that will come into play. So, all those things should work hand in hand, and if you look at that PaaS thing on the left side of the things, there are definitely other PaaS things other than there are things for remote CDC manager, VM resource manager, green resource manager, thermal profiling, cooling manager. These are different type of applications which are running at the infrastructure itself to have a more holistic approach. Now, this also we started at the end we basically shown this. So, if you look at that overall what are the different components or what are the different aspects of this SCC rather, sustainable cloud computing. So, one will is the application model, right, what sort of application, how we have tuned the application, the same application may be more energy friendly if you have a more optimized way of planning it. There are things for virtualizations, that because of virtualization is one of the major aspects of cloud computing. So, how you handle that, whether VM migration, storage migration, things like that. There are things for waste heat utilization. There are waste heat because which are heat generated, either you throw it out, whether there is a possibility of using this heat, right. Like there are concept of vapor evaporation, right. Once you evaporate, then basically it cools down and things like that. Whether it can be used for this type of things. Thermal aware scheduling, right. So, scheduling mechanism, architecture which are thermal aware, right. So, whatever architecture, the scheduling, whatever we are following in our mechanism, whether these are thermal aware, like the one is that doing efficiency in different terms, and other way looking at it, that whether it can be thermal aware. There can be renewable energy which plays a big role, like energy source, storage device, which location, etc., and these are the renewable energy. There can be renewable energy, and once renewable energy is there, so we require some sort of energy management, not only renewable energy, any energy stuff we require a energy management, right. So, energy management to the IT infrastructure itself, like processor, memory, storage, or the cooling mechanism, or network, or even when to switch from renewable to the our standard energy sources, and things like that, right. Whether if the load is increased, whether it is good to have work on with our standard energy sources, which get the energy from this fossil fuel, etc., which may be more quickly to deliver power, or renewable energy, that those things are to be worked out. And of course, make this whole show run properly, we need to do a capacity planning, right. That is required for any things, because now if you see this cloud computing, it is not only putting some infrastructure and set it run. So, it is much more than that. Why we are doing that? So, that we can make this sort of infrastructure sustainable, right. So, capacity planning. So, power infrastructure, IT sources, workloads, based on that we need to plan the capacity things, right. Not only that, we need to have predictive models, like what we are heading to, if this is my requirement down the line, if we going to next stage of things, whether there is requirement increases, and what sort of requirements are there, and things like that. So, that is important for capacity planning and doing for looking for the in something which is something futuristic manner. So, as we discussed, so application model, the application in this, the application model plays a vital role, and the efficient structure of the application can improve the energy efficiency of the cloud data centers, right. Application model can be data parallel, function parallel, message parallel. The what way we are trying to look at, whether it may be data parallel, it can be function parallel, that means parallelism in executing the function, or it can be message passing and things like that. So, based on type of application, we can have different application model, and this model can be what we say energy aware or thermal aware type of things, right. How much consumption of the energy, how much heat generation, things like that. Another aspect is the energy management, as we are talking about. So, energy consumption of the processor, memory, storage, cooling of the things, or from some reported work, as the document we are following. I have shown the reference in the previous slides. So, what some study shows that for processor it is 45%, next comes the cooling 20%, and this memory, storage, networking, these are the 15, 10, 10 type of things, right. So, we need to look into this when we look for the energy management, who is basically main takers or the consumer of the things. Appropriately we need to look into the things, right. 10% cooling requirement, if we can reduce, it may reduce more than the same 10% if we want to reduce for the storage, etc., right. So, power regulation approaches increase the energy consumption during workload execution, which affects the resource utilization of the CDCs, right. So, if we have a power regulations across the thing without, so when at the peak time the overall performance may be affected, right. So, there are things like we have last class also we discussed that DVFS attempts to solve the problem of resource utilization, but switching of resources between high scaling and low scaling modes increases the response time and the service delivery delay, right. So, too many switching may have effect on the SLA per se, right. So, again putting server in sleep mode, then wake up things when demands come also is challenging. Thus, improving energy efficiency in looking at different aspects may have a better way of sustainability and keeping the resource utilization, reliability, performance of the server in a within the threshold or in a optimal way. So, thermal aware scheduling, as we discussed. So, component of thermal aware scheduling are the architecture and scheduling mechanisms, right. So, can be different architectures, single core, multi core. So, heating problem during the execution of the workload reduces the efficiency of the cloud data centers, right. To solve this heating problem of the CDC, thermal scheduling is designed, right. So, what we see that it present day thermal aware scheduling or whatever you use is mostly focused on reducing power usage efficiency, right. And but PUE reduction may not reduce the total cost of ownership always. Anyway, that is another stuff to look at, but nevertheless thermal aware scheduling is again a need and becoming popular for sustaining this cloud infrastructure. Virtualization, because the whole cloud is primarily concept is based on virtualization. So, during execution VM migration performed to balance the load, etc., right, due to lack of on-site renewable energy, workload can be transferred here. So, this overall now once you transfer the VM from one to another. So, there are a lot of implication to that, right. We have seen that how VM migration can be looked into. So, though this is also one major component to to be looked into in realization of the sustainable cloud computing. Capacity planning, as we discussed, this cloud service provider must innovate, must involve an efficient and organized capacity planning mechanism, right, to attain expected return on investment. Because the if you see the CSP's point of view, so they want to look at whole thing as a investment, right. One major component is the investment and there is a return on investment. There are definitely SLA violations to be avoided, customer satisfaction and customer what we say likingness for the infrastructure or the for the CSPs, also all those factors, but nevertheless there should be a return on investment, right, that whatever is there, and investment in most of the cases are has to be done upfront and the utilization slowly grows grows up, right, or slowly the growth utilization slowly increases and things like that. So, they have to need appropriate planning or appropriate capacity planning, not in terms of hard resources, also in terms of that what we say regular resources, right, like power, how to handle this waste energy or waste heat, what should be the cooling mechanism. So, it should be more adaptive and things like that, and we need there is a need to do a full fledged capacity planning. So, there is a need of effective capacity planning for data storage and their processing also, right. So, it is not only the computing things like if we when we talk about IT infrastructure, we want to include storage, networks and things like that. Renewable energy, as we know that either solar, wind and things like that. So, energy storage device and location like whether it is off site, on site, how much with and those things becomes important. So, carbon uses efficiency CUI can be reduced by adding more renewable energy, but there are a flip side that renewable energy getting when there is a huge demand, whether this renewable energy source can handle this demand. So, it need to be looked into that how to switch between the renewable energy and our standard energy sources and things like that, right. So, cloud CDCs are required to place near the renewable sources to make cost effectiveness, and if you see different renewable energy sources is required say large span of area, whether if you look at say solar power thing or solar cells. So, it is it requires a sufficient space, or even wind energy where you need to place all those windmill in a different places. And waste heat utilization, the cooling mechanism of the heat transfer model plays an important role to utilize the waste heat things, right. So, what is happening that lot of heats are being generated by the infrastructure. Now, this heat either this what in our standard practice, the cooling mechanisms basically support this heating thing, right. Basically not I should not say support, basically take care of this heating mechanism and cools it down, whether there is a way to utilize this waste heat, right. So, this vapor absorption based free cooling techniques can help in reducing the cooling expenses, right. So, there are different techniques which are used. So, energy efficiency CDC can be improved by reducing the energy using the cooling. So, it can be if the waste heat is utilized in some way or other, then it may help in better cooling mechanism. So, now we with this basic model in concept, we try to see there in another the taxonomy, the overall taxonomy of the sustainable cloud computing, and with respect to the mostly with respect to the this different aspects and components of the features what we just discussed, right. So, needless to say that with huge proliferation of IoT devices and means extreme uses of this our IT infrastructure for different other purpose, like several location based service or mapping services, video conferencing, online feeding of live streaming of different events and games, etc. So, it became a huge need of computation, and there is a with cloud computing in place, there is a obvious fallback to this cloud computing infrastructure, right. So, in order to make it sustainable, right. So, this cloud computing must be energy efficient and sustainable to fulfill the ever increasing user needs, right. So, there is a ever increasing needs of the user, and this cloud computing should be sustainable. So, research initiative on sustainable cloud computing can be categorized as follows. One is that application design, sustainability metric, what are the different sustainability metrics are there, starting from its something which is performance centric to cooling to power to and different aspects of the things, right. Capacity planning as we are discussing, energy management, virtualization, thermal aware scheduling, cooling mechanism, renewable energy and waste heat energy utilization, right. These are all important because most of these CSPs and data centers are working round the clock, right. So, it never stops, and though the user need may be the demand may vary, but the system need to adapt with the things, right. There is a need of predictive model that what we are going to get in future and plan accordingly. So, next couple of slide we will look into that different taxonomy again presented in that reference which is given below. right. So, those are taken from there. I am referring that, and not only that, I rather encourage all of you to have a read on this particular paper, or rather whatever in the references also we mentioned, I mentioned. So, if we look at the application design, so there are distinct component. One is that looking at that QoS mechanisms, that overall application model, workload type, architecture, and there are other components like if you QoS time, cost aspect, workload management, like what are the different critical critical interactive mechanisms, or there are batch style, or what, there are different type of mechanisms, right. So, what we try to look at, the design of an application plays a vital role, and effective structure of a there is a small typo of an application can improve the energy efficiency, right. And different type of application may need different type of what we say designing, right. Say something a parallel computing type of application may be different when we have something called a streaming application and things like that, right. So, the resource manager and the scheduler follow different approaches for application modeling. So, the resource manager and the scheduler follow different approaches for application modeling. To make infrastructure sustainable and environmentally eco-friendly, there is a need for green ICT based innovative applications, right. So, we need to look at more applications models or designs which can cater to this means energy efficient or thermal aware type of things. Next one is the what we want to discuss is the sustainability metric. There is a big one, right. So, one part if you see that more of the performance related metric, which can be related to the cloud provider like throughput, application, security, and so on and so forth. Other is the cloud user satisfaction, response time, correctness, reliability, etc., what the user is looking for, right. So, this is the performance, and other things like we have at the bottom mostly that waste heat utilization, cooling mechanism, right, thermal aware scheduling metric, energy management metrics, and these are the things, right. Whereas, there are issues of virtualization metric, like which looks for that different virtualization techniques and things, what should be the say if we have any virtualization, any migration issues or other things, how need to be handled like that. There is a thing for capacity planning, like we already discussed, like looking at the capacity and also predicting that say uses of the infrastructure in terms of memory, in terms of storage, in terms of CPUs, GPUs, and things like that. And there are renewable energy matrices for bringing down the carbon footprint and so on and so forth. So, these are the different sustainable metric which you need to keep in mind, right. So, once we employ or deploy some mechanisms which are which supports this sustainable cloud computing, you need to look at that that how effectiveness of that mechanisms by looking at the different metrics, right, one or more of the metrics which are here. Capacity planning, as we discussed, is important things like with respect to what are the different components like IT, cooling, power, infrastructure, etc. With respect to IT workload, application model, things like auto scaling, utility, different utility functions, those are things which are required for this capacity planning, right. Then we have energy management things like as we discussed, it can be overall management of the energy. So, a system is an important factor because the energy need to be as at a optimal level, so that the performance are not disturbed and SLAs are not violated, or and use the minimum energy, right. So, improving energy use reduces electricity bills and operational cost. Essential requirement of sustainable computing are optimal software system design, optimized air ventilation, and installing temperature monitoring tools for adequate resource utilization, which overall which may increase the energy efficiency. So, if you see, there are things called static way of static management, which mostly of the system level and the CPU level, and there are a lot of dynamic things like resource management, resource consolidation, configuration components, which looked into the different aspects of energy management, but nevertheless is one of the major factor. Virtualization we have already discussed is an important part for the not only for the sustainable cloud computing or CDCs, but it is the core of the philosophy of cloud computing, right. So, this once we have these virtual machines, if there is a virtual migration, VM migration, VM elasticity, VM load balancing, VM consolidation, fault tolerant and scheduling, all those aspects need to be can be made in a efficient way, so that the overall energy requirement or can be minimized, thermal heating can be minimized, and so on and so forth, if including waste heat type of things, right. Thermal aware scheduling, as mentioned earlier. So, consists of if you look at a CDC or any data, for that matter any data centers or any rack. So, it has a chassis racks to replace the servers to process the IT workload, right, to maintain temperature of the data centers, right. Server produce heat during the execution of the IT workload. The processor is an important component of the server and consume most electricity, right, processor things. But both cooling and what we have seen few slides before, the cooling mechanisms or other type of computing mechanisms also take or other IT infrastructure also have a huge amount of this power generation, power requirement and thermal heat generations are there. So, there are different aspects like architecture, heat modeling, thermometer, scheduling, monitoring awareness and simulations and things like that. Then we have the cooling management. So, the increasing demand for computation, networking, storage expands the complexity, right, size and the energy density of CDCs exponentially, which consumes a large amount of energy and reduces the huge amount of heat, right. So, we have appropriate cooling mechanisms which need to be in place in order that the everything works faithfully. To make CDCs more energy efficient and sustainable, we need an efficient cooling management systems which maintain the temperature of CDCs, right. And then we have the renewable energy, right, different sources like it can be solar, wind or in sometimes like hydropower, water generated energy which has a near zero carbon dioxide emission, things like that, that can be employed. And of course, if we need to these, then we need to have appropriate workload scheduled there. So, which sort of workload to be scheduled, what are the different sources of energy, whether it should be location aware, whether we can have this storage device, how to maintain with this renewable energy and things like that. Then finally, we are having this waste heat utilization, right. So, reuse of waste heat is becoming a solution for fulfilling energy demand in the energy conservation system. So, waste heat means heat generated by the system itself, which are cooled down, but if we have a mechanism of utilizing this, reusing this waste heat, then we efficiently we we can basically overall what we say like overall this green computing aspect we may put more emphasis on this, right. So, that one way of what is seen in the literature, people are trying for vapor absorption based cooling system, as we are discussing in the beginning of the thing, can use waste heat and remove the heat while evaporating, right. So, vapor absorption based free cooling mechanisms can make the value of PUE ideal by neutralizing the cooling expenses. So, it will have a not only monetary wise, but also you can have utilization of the things, right. So, if we look at the overall sustainable cloud computing, so this ever increasing demand with IoTs and different type of different sensors, even this huge proliferation of this drone level drone operations and capturing different images and other things. So, we get a huge volume of data, right. Apart from that, there are streaming data and things like that. So, so we need to have more efficient. So, which dictates this some sort of a ever increasing form of cloud infrastructure, which may not be feasible up to a limit. So, what we need to do, we need to have this all these component together and make a sustainable model, right. So, that it sustain over time span. So, this what we see this next generation or the today's cloud computing must be energy efficient and sustainable to fulfill this. Sustainable computing CDCs are powered by renewable energy sources, kept more towards means this near the power generation things, maybe more in a more cool environment, right. There are other issues of environmental issues, right. So, that overall carbon footprint is reduced, right. So, sustainability with high performance and reliability is one of the primary goal of this cloud computing or today's cloud computing infrastructure. So, with this let us end our discussion today. There are very nice references, some of them I have put here. So, I encourage you to go to these references, that will be most of the things we basically taken from these different references, but I think that reading the differences will be good for you. Thank you.